Download this code from codegive.com, link in the description below. OK, let's dive deep into openssl compilation warnings. This tutorial aims to provide a comprehensive understanding of why these warnings occur, common types of warnings, and, most importantly, how to handle them effectively. We'll include code examples and practical strategies to keep your openssl integration clean and robust. Why compilation warnings matter. It's tempting to ignore compilation warnings, especially when your code seems to compile and run fine. However, warnings are your compiler's way of saying, "Hey, I see something potentially problematic here." It might not cause an immediate crash, but it could lead to unexpected behavior, security vulnerabilities, or maintenance headaches down the line. Ignoring warnings, especially in security-sensitive libraries like openssl, can lead to serious issues. Undefined behavior. The code might do unpredictable things on different platforms or with different compiler versions. Memory leaks. Unused variables or improper resource management flagged by warnings could lead to memory leaks. Security vulnerabilities. Some warnings might indicate potential buffer overflows or incorrect data handling, which can be exploited. Maintainability. Code riddled with warnings is harder to understand and debug, making future maintenance difficult. Portability. What works on one system might not work on another, depending on compiler configurations and platform differences. Understanding the openssl compilation process. Before addressing warnings, let's briefly review the openssl compilation process. When you build an application that uses openssl, you essentially go through these steps. 1. Header inclusion. Your source code includes openssl header files, example openssl/ssl.h, openssl/bio.h, etc. These headers define the functions, structures, and constants you'll use. 2. Compilation. The compiler translates your source code and the included header files into object code. This is where warnings are generated based on the syntax and semantics of your code, as well as how you use openssl functions. 3. Linking. The linker combines your object code with the openssl library, usually libssl.so or libcrypto.so on Linux/Unix-like systems, or their equivalent on Windows, to create the final executable. Common openssl compilation warnings and how to handle them. Let's look at specific warning categories and how to address them. 1. Implicit declaration of functions, or incompatible implicit declaration. Cause. This warning occurs when you use an openssl function without properly including the necessary header file that declares it. The compiler makes an implicit declaration, guessing the function's return type and arguments, which might be incorrect. If the compiler makes an incorrect implicit declaration, it can result in undefined behavior. Example. Solution. Always include the correct header file. Consult the openssl documentation or manual pages for the specific function you're using. In the example above, adding include openssl/rand.h will resolve the warning. 2. Incompatible pointer type /type mismatch warnings. Cause. These warnings arise when you pass a pointer of one type to an openssl function that expects a pointer of a different type. OpenSSL functions often deal with raw memory and void asterisk, so type mismatches can easily occur if you're not careful. Example solution. 1. Review function signatures. Carefully check the documentation for the openssl function to see the exact type of pointer it expects. 2. Explicit casts. Use sparingly if you're absolutely certain that the type conversion is safe. Example, you're converting from a more specific type to a void asterisk. you can use an explicit cast. However, be very cautious, as incorrect casts can lead to memory corruption. For example, bio** fp. 3. Unused variable warnings. Cause the compiler detects that you've declared a variable but never used it in your code. While not usually a serious error, it can indicate a potential logic error or unnecessary code clutter. Example solution 1. Remove the variable if the variable is truly unnecessary, simply delete its declaration. 2. Use the variable if you intended to use the variable, implement the logic to do so. 3. Suppress the warning, as a last resort if the variable is intentionally unused. Example for future use, you can use compiler-specific ways to suppress the warning, example void, unused _variable, to indicate that the variable is intentionally ignored. 4. Format string vulnerabilities, string formatting warnings. Cause these are very important warnings. They occur when you use format strings, like in printf, sprintf, etc., with user-controlled data. This can lead to a format string vulnerability, where an attacker can inject malicious code into the format string and potentially gain control of your program. Example solution never use user-controlled data directly as a format string. Always use a constant format string and pass user data as arguments. 5. Deprecated function warnings. Cause openssl occasionally deprecates functions, meaning they are no longer recommended for use and might be removed in future versions. The compiler will issue a warning when you use a deprecated function. Example this depends on the openssl version you're using, as deprecated functions change over time. Solution replace the deprecated function with its recommended replacement. The warning message often provides hints about the correct alternative. Consult the openssl documentation for the updated API. For example, replace sslv3_client_method with tls_client_method, or tls_method. 6. Conversion may lose information. Cause these warnings occur when you're implicitly or explicitly converting a value from a larger data type to a smaller data type. This can lead to data loss if the larger value exceeds the range of the smaller type. Example solution 1. Use the correct data type *. Choose a data type that is large enough to hold the values you're working with. 2. Check for overflow *. If you must convert to a smaller type, add code to check for potential overflow and handle it gracefully, example return an error or clamp the value. 7. Signed/unsigned mismatch. Cause when comparing or assigning signed and unsigned integers, the compiler will often warn that it may result in unexpected behavior. The signed integer might be interpreted as a very large positive number by the unsigned integer, resulting in unexpected results. Example solution 1. Use the same type * use same type of integer for comparison or assignment. 2. Cast explicitly * cast one of the variables so that both have the same type. Practical strategies for handling openssl compilation warnings. 1. Enable all warnings * use compiler flags like wall, for gcc/clang, or /w4, for Visual Studio, to enable the maximum level of warnings. This will help you catch potential issues early. 2. Treat warnings as errors * use the wearer flag, gcc/clang, or /wx, Visual Studio, to treat all warnings as errors. This forces you to fix warnings before your code can compile. This is especially useful in CI/CD pipelines. 3 Static analysis tools * Use static analysis tools like Covariety, Clang Static Analyzer, or SonarQube to identify potential issues beyond what the compiler can detect. These tools can help you find memory leaks, null pointer dereference, and other vulnerabilities. 4 Code reviews * Have your code reviewed by another developer, especially someone familiar with openssl. A fresh pair of eyes can often spot problems you might have missed. 5 openssl documentation * Always refer to the official openssl documentation for the correct usage of functions and data structures. 6 Test thoroughly * Write comprehensive unit tests to verify that your code behaves as expected, especially after making changes to address warnings. 7 Compiler version matters * The warnings you see might vary depending on the compiler version you're using. Test your code with different compilers to ensure compatibility. 8 Platform-specific considerations * Be aware that some warnings might be specific to certain platforms, example Windows versus Linux. Code example, comprehensive openssl example with warning mitigation. Explanation of mitigation strategies in the example * 1 includes * All necessary headers are included upfront, openssl/ssl.h, openssl/bio.h, openssl/air.h, openssl/ran.h, to prevent implicit declaration warnings. 2 Error handling * Error checking is performed after each openssl function call. Error_print_errors_fp, str, is used to print openssl error messages, which can help in debugging. 3 Memory management * ssl_ctx_free, and ssl_free, are used to free allocated memory for SSL contexts and SSL objects, respectively. This helps prevent memory leaks. 4 Explicit casting * A explicit cast, int, buffer_size is used to resolve potential conversion warnings during the call of rand_bytes. Make sure you're handling potential overflow if the size of the buffer is too large. 5 Buffer size * The code avoids buffer overflows by ensuring that the size of the buffer passed to ssl_read is less than or equal to the size of the buffer allocated. 6 Null termination * The received message is explicitly null terminated after reading from the SSL connection to avoid reading garbage data. Key takeaways. * Treat compilation warnings seriously, especially in security-sensitive code. * Understand the root cause of each warning and address it appropriately. * Use compiler flags, static analysis tools, and code reviews to improve code quality. * Test your code thoroughly after addressing warnings to ensure that your changes haven't introduced new issues. * Keep up to date with openssl versions and deprecation notices. By following these guidelines, you can write cleaner, more robust, and more secure code that integrates effectively with openssl. Good luck.